What is a tool? It's an object to make a job easier, right? Well, I've got a task that I often avoid doing just because it's such a hassle to set up. Putting rounds on corners. The precision way to do this is to lug out this massive rotary table, tram it on the mill, then find some combination of clamps or a makeshift fixture plate to hold the part I'm trying to round. But I don't always feel like doing all that. As an alternative, I can quickly grind these on the belt grinder, but this is a much less elegant approach and leaves a lot to be desired on the precision side of things. So I need something in between. A tool to make this job easier while also being accurate. A tool like a quick change radius fixture. I've already gone into great detail about how I drafted up this project, but I never really explained what I was drawing. So here it goes. At the heart of this tool is a rotating fixture plate that I can clamp in a vise. The top plate has an array of mounting holes, and at the center is an optional hole for part locating plugs. Since this definitely isn't anything like a rotary table, it doesn't have a hand wheel. So to spin the table, I'll include a handle, which of course needs a fancy brass knob. And since I'm making things fancy, I might as well include some adjustable hard stops on the table perimeter for accurately swinging through common angles like 90 and 180 degrees. Finally, to really turn it up to 11, I've included some dovetail grooves in the top plate. These will accept a set of custom self-squaring guides as another option for repeatedly locating parts. Okay, I might have gone a little overboard on the features, so we'll see if I can actually get all of this made. But I still feel like this is a really good design and will solve a lot of my corner rounding frustrations. So let's get to work. Most of the project will be built from material I already have, and the few things I did need to order for this build literally just arrived, so I can pretty much begin wherever I want. But I guess the best place to start will be with the plate at the top, aptly named the top plate. The major dimensions for this part are right at 8 inches by 1 inch, and it looks like the McMaster folks kindly left me an 1/8 inch to play with in both directions. So I shouldn't have to think too hard about how to get my part out of this material. Sometimes it's the little things. You know, I've been in a bit of a foul mood lately, and I think I just figured out why. After all that time spent on the design of this one, it's been way too long since I've actually made any chips. So I'm wondering if... oh yeah, inner peace has been restored. Not the healthiest chip formation though, but I'm just getting warmed up. Maybe some different settings. Meh, still pretty stringy, but that surface finish. There's not really a lot I can do about it looking different in the middle. This is such a large diameter to try and maintain optimum speeds and feeds across. Fortunately, a lot of that unsightly center will get removed later on for the pivot shaft. With side 1 faced, I can flip this over and start on the other side. But my approach is going to be a little bit different. I'll start by first center drilling the unfinished face. And now for the rub. I need to face this to thickness, but I also need to turn the outside down to diameter, which isn't exactly possible because the chuck jaws are in the way. So here's where things get a little bit sticky. I'll chuck up a round aluminum scrap, and then I'll mount my steel plate to that aluminum. And to do the mounting... oh, and also this. I'm going to give the old superglue trick a go. I've seen folks do this for thin and small parts, and it frees up the whole perimeter for machining. And while this is neither thin nor small, I'm hopeful this will work for me as well. And if it doesn't, well, I'm ready for that too. I'll face the aluminum to true it up with the lathe, and then I can start the preparations. First, cleaning the parts with acetone, then applying painter's tape to the mating surfaces of both the aluminum and steel plates, making sure not to overlap it. I could of course directly superglue these plates together, but from what I hear, that makes cleanup and disassembly a real pain. I'll use a blunt object to make sure the tape is properly adhered, then this is ready for the glue up. I'll coat one side with cyanoacrylate superglue, use the tailstock to center and clamp the part, and then we wait. What to do in the meantime? Oh, I know. I'll get the rotary table set up. I'm going to be making heavy use of this very soon, but I first have to get it clamped down and trammed square with the mill. Tramming a rotary table like this isn't always necessary depending on what you're doing, but since I'll be using this table in both the horizontal and vertical position on the same part, this will ensure everything translates when I make that move. Okay, that's ready to go, and so should my glue up situation. I do want to check something before I go to town machining this though. The whole point of this setup is to keep the back face I just glued running true with the lathe. And with all the tape and superglue in between, I'm curious just how true that came out. So I've got just enough of a sliver here to run an indicator on. Only a half thou of run out. Not perfect, but not bad either. I think I can live with that. You know, maybe it's not the best idea that my first attempt with superglue work holding be on something so large. But you know what they say, go big or get out of the shop. I'm not excessively stupid though, so I will turn this on from a distance, just to give me more time to duck. Oh, well, that was uneventful. But that's a good thing. I am going to keep the live center engaged just in case though. Let's finish out the lathe work. The first passes on the outside are a little chaotic while breaking through that hard mill scale layer. But then things smooth out as I get into fresh steel and take this to diameter. Now for the face. I'll need access to the whole face, so out comes the live center. Don't worry, it'll be alright, buddy. See, I told you. With it down to thickness, the last task is to add the bore. So after drilling out the center, I'll bring the boring bar in to finish out the two press fit diameters. And it just wouldn't be right if I didn't add some chamfers. That's all the lathe work for this part, so it's over to the mill to wrap up. But the chuck is coming along for the ride. That's because I'm going to use my trusty rotary table chuck adapter. This will make it super easy to keep everything concentric and square as I switch between the machines. Well, normally that's the case. I seem to have had a minor oversight. With the stack up of all these parts, I pretty much left myself no room to even fit a drill chuck in here. This setup just got a whole lot more complicated. I guess it's time for a little improvisation. Maybe you've picked up on what I'm doing here. I've cut these pockets in the side of my aluminum plate so that I can clamp it directly to the rotary table. Now I suspect that since this bottom aluminum face hasn't been machined, I'm going to have a little trouble with this setup. But only one way to find out. I'll just roughly center the part with a coaxial indicator, and then drop a dial test indicator on the top face. Sure enough, you can see the part wants to rock a bit on some inconsistency on that bottom surface. And rotating the table reveals even more fluctuation. So how am I going to correct this? Well, this seems like a perfect job for some shims. I have this precision feeler gauge stock that should do the trick. I'll first start by cutting 3 pieces of the 10 thou thickness to rest the part on. But before I slip these in place, there's a very subtle but important thing I should mention. Since I cut this stock with scissors, the ends are mildly deformed. It may not seem like much, but this deformation could wreak havoc on the measurements to come. How do I know this? Let's just say this isn't my first attempt at leveling this part. Anyway, a quick brush on the grinding wheel takes care of this issue. And then I can drop the 3 shims in place, making sure to put them under the areas I'll eventually clamp down on. This gets the part up to a stable starting point away from the inconsistencies on the bottom. From here, it's just a matter of measuring the deviation at the 3 shimmed locations. Then adding whatever thickness stock is needed to bring that top face up level. And with the indicator reading within a few 10,000ths around the whole perimeter, I can bring in the step clamps to secure everything down to the table. And of course, just double check that nothing moved in the process. If there's anything I've learned in this hobby, it's to always, always, always double check. Now after all that, I can at last get back to machining. Starting with the dovetail grooves. Yes, I know this won't cut a dovetail. Hold your horses. I only have one dovetail cutter at my disposal, and I really don't want to wreck it. So I'm going to do all the heavy lifting by first removing most of the material with this 2-flute slot mill. Nothing too eventful here, but it is pretty satisfying when you perfectly dial in the speeds and feeds and send the cutter on its way. Once at depth, a couple passes along each side open the slot to final width and also position it right where I need it on the plate. Now for the fun stuff. I'll be honest, even though I know this dovetail cutter is meant for this exact operation, the spindly little stem on here has me a little apprehensive. But I've basically made this job as easy as possible for this tool, so here it goes. Well, that seems to be doing okay. I'm 2 for 2 on sketchy setups that work out just fine in the end. Good day in the shop. Because there's potential for small amounts of runout and deflection in the cutter, I've given myself some latitude by designing this dovetail slightly larger than the cutter itself. So let's see where that first pass ended up. The depth looks great. I'm within half a thou along the length of the slot. To measure the width though, I'll need to use 2 gauge pins, which I don't have, so a couple end mill shanks will have to work. My math tells me this needs to be at 0.258, so 8 thou to go. Similarly, the gauge pin lets me measure the dovetail position relative to the plate itself. This is a little tricky to measure, so a 1, 2, 3 block just helps me keep the caliper square. I'm reading 5.375, which is 4 thou over what it needs to be. So it looks like an even 4 thou pass off of each side of the groove should put me right at spec. Perfect. With the first dovetail spot on, I can rotate the table 90 degrees and whip up the second. Of course, it isn't strictly necessary to rotate the table to do this second groove. I could just cut it using the y-axis. But when the machining gods give you an x-axis power feed, you use the x-axis power feed. Alright, the grooving is complete and those turned out pretty much perfectly. Now it's time to poke a bunch of holes in this thing. I've designed an alternating pattern of 36 holes in this top face, so the first step is to spot drill each location. After which I can work my way back across the part with a tap drill. I don't want these holes to end up being passageways for chips and coolant in my final assembly, so I'm not drilling them all the way through. I'll take one last trip across the part with a chamfering bit, then it's time to thread these suckers. I was smart this time and bought a spiral flute bottoming tap specifically for this task. This lets me thread as deep as possible into the holes and not have to worry about chips since they're evacuated out the top. The only downside of this is I don't really feel comfortable power tapping into blind holes, so I got my workout in on this one. With those 36 holes taken care of, I just have 8 more to do. Only these will be on the perimeter, so up goes the rotary table. And of course I'll have to tram the backside square to the mill. I'll use the edge finder to reset my datums, and then I can start drilling. Except I've decided to make one small change. My hole positions were going to be here, and as you can see, their depths would be limited by the top holes they would intersect with. But it occurred to me there's no real reason I couldn't just shift everything 10 degrees to the left. So that's exactly what I'm going to do. The process here is pretty much the same as the top holes, only the chamfers are much larger since they will be what aligns the handle I'll make later. I also didn't have much room in here for a tap wrench, so I had to power tap them about halfway, then switch to manually finishing them. Okay, that's pretty much it on the top plate. The very last thing, and what could quite possibly be the hardest, is to separate my part from the aluminum. There are a few methods I've seen, but I'm just going to start with some good old brute force. That was not hard at all. I'm officially a convert to the superglue technique. Even more so since cleanup is super simple with just a bit of acetone. I gotta say, this part went about as smoothly as possible, and it's only been, oh shoot, we're already 14 minutes into the video. Time to engage the afterburners if I want to have anything to show by the end of this. Let's jump right into the pivot shaft. It's mostly just some precision diameters with a threaded end and a bore. Easy enough. I have a tool steel slug that will be perfect for this. After facing and center drilling the end, I can work on the 4 diameters. The 2 on the left are dialed in for a 1 thou press fit into the top plate, then a slightly smaller section for a half thou slip fit for a pivot bushing, and lastly, taking 5 thou off the diameter where the threads will go and also hogging away a thread run out. Easy peasy. Now to cut the threads. I've set the machine up to cut 20 threads per inch, so after taking a scratch pass... Hang on a minute, something feels off. Oh, you doof. This should have been 16 threads per inch, not 20. What was I literally just saying about always double checking? Seems I'd better cool my jets a little. Luckily I caught it early, so I can just correct the thread feed settings and try again. And after quadruple checking that it's right this time, proceed deeper. Now normally I would have a female threaded part to test this on, but that isn't the case here. So I have to use the 3-wire method to measure the thread depth. I've grown fond of this online thread wire calculator that lets you put in the thread size, thread class, and wire diameter, then it spits out an over-the-wire measurement range. Which of course I prefer to keep on the tight end. Alright, that's all I can do from this side, so I'll go ahead and part it off and finish out the other end. I'll be adding a precision bore to this side, and it needs to be centered with the rest of the shaft. Lucky for me, the tense indicator shows I'm pretty much bang on without any fuss. Wonderful. From here I'll just face the end to length and chamfer the outside, then drill a through hole, followed by a larger shallower hole, and then bring in the boring bar to take it to size. We're really moving along here, I just have to be careful not to go too fast. Up next, I think I'll switch mediums and work on the bushings, so I get to play with some Delrin. Woohoo! But of course I'll have to switch chucks for this. Ugh. You know, I've seen some other makers snap their fingers to magically skip past some boring or cumbersome task. Nope, I guess I just don't have the touch. Alright, here we go. The first bushing is sort of a long skinny one, so I'll first drill out the center a little undersized, then move on to turning down the outside. Man, this is some nice material to turn. I normally rank brass right at the top of my favorite materials to machine, but I think this might be a close contender. Just look at that finish. Anyway, I'll save finishing out the bore until later and just part this to length. Though that didn't come out as cleanly as I'd hoped. I suppose that's mostly due to the neutral angle parting insert I have in here. So I'll just manually remove this burr with a countersinking bit. And I'll also go ahead and swap this insert for an angled one that should prevent this problem on the next bushings. The remaining 2 bushings are short and fat, basically washer shaped. I've already got the center drilled out from before, so I'll bring the boring bar in to open this up to the final diameter, then face, turn, and part the 2 bushings from the stock. 3 bushings down and just 1 to go. But this one isn't as straightforward. Not only is it a lot larger, but it's got some special geometry involved, so this should be good. Well, there's a lack of foresight. I should have worked on this bushing first before flipping all the jaws. Now I have to flip them right back to where they were. Let me just try this one more time. Hey, it worked. It actually worked. I guess it's like a lot of things where you have to start small and then work your way up. At any rate, I could really get used to this. To start this part, I'm just going to partially face the front, then turn down the diameter to size. While this material is large, the actual bushing is just a ring I'll cut from the perimeter. Next, I'll need to drill the mounting holes, so it's over to the rotary table again. Whoa, no way. The chuck adapter is already set up and waiting. This must have been where all those extra snaps went. Actually, now I wonder what else I'm going to find finished around the shop. Anyway, with that time saved, I can move right on to the drilling. First the 4 screw clearance holes, then swapping to an end mill to cut the counterbores for each of the screw heads. And of course a dainty little chamfer on each of these. Now it's back to the lathe to finish this out. I mentioned before that this is a ring-shaped bushing, but it would be a real waste to bore out the entire center. So instead, I'm going to make use of a special tool I made a while back. A trepan cutter. This is like a parting blade, but has a curved clearance on the side to allow it to cut a circular face groove. So I can bring it in to cut the idea of the bushing without having to turn $50 worth of Delrin into shavings. Just a small handful. I'll take one last skim across the face of the bushing just to guarantee it's true. Chamfer the inside and outside edges, then bring in the parting blade. If I did everything correctly, that should intersect with the face groove and... bingo. After a quick deburring on the two raw edges, this bushing is complete. And it looks like it came out dead parallel on the two bearing faces, just like I need. Perfect. That's the top plate, shaft, and bushings all finished. So next is the base plate that I'll mount to. Luckily, I have the perfect piece of stock for this. Look familiar? Well, it should. This was the donor for the massive fly cutter build I did last year. I'll liberate the blank I need from this, and then I can get to work on turning it. This part is similar to the top plate in that I'll need access from multiple directions to machine it. So after facing the first side, I'll get this taped and superglued just like before and we can get to work. The first step, of course, is to get the diameter and thickness down to size. Now for something a little different. I need to cut a trapezoidal groove in the perimeter. This is just like a V groove, only more like a long V. I'll start by first using a pointy threading tool to describe the groove's width. I'm marking about 10 thou inboard on each side though, so I have some wiggle room for the fine adjustments later. The angled sides of the groove are each 45 degrees, so I'll need to set things up so I can cut both of these simultaneously. Adjusting the compound slide to 45 degrees takes care of one side. Then using 45 degrees worth of angle blocks, I'll position the left side of the cutter to match. Now, as I take cuts, I can wheel the compound in to shape the right side, then feed the carriage across to flatten out the bottom and form the left side. Pretty slick, right? To measure my progress, I'll use another gauge pin technique, measuring the horizontal position with a depth micrometer, then the groove's width with the caliper spanning across the part. Of course I had to do a little math to work out what these values should be, and after a few final adjusting passes, I get it more or less spot on and that's the groove wrapped up. Alright, what's next? Let's knock out the bore real quick. This is similar to the bores I've already machined so far. Only this time, once I'm to diameter, I'll go ahead and insert the Delrin bushing I made earlier and bore it to size as well. And this is why I only pre-drilled the bushing when I made it before. Had I bothered to turn it to a precision bore, that measurement would have just closed up as soon as I pressed it in place. So waiting until now ensures I open this up to a perfect fit with the pivot shaft. Which brings me to the final lathe operation. The groove for the ring bushing. Another perfect job for the trepan tool. Turning this in the same setup is just another guarantee that all the bushings end up coming out square with one another into the body itself. Stellar. Just a few more holes to drill in the mill and this part is a wrap. I'll get this dialed in and shimmed on the rotary table where I can drill and tap the 4 bushing holes. Then 4 more in the center for a vise mounting block. And with those finished, I'll sand this up and start working my way around the perimeter adding the vise stop mounting holes at 10-degree increments. By this point in the project all I can say is thank goodness for stools. Let's get this off of here and cleaned up. I'm building up quite a pile of parts here, and I've actually got enough going on that I can start test fitting some stuff. Let's see how the bushing fits. Nice. The top plate goes on next, but it's not really going to mean anything unless this pin is in place. So it's over to the hydraulic press. I don't want to ding up any of the surfaces, so I'm taking care to pad things with paper or softer aluminum. And if I machined everything correctly, the top face of that pin should be dead flush with the plate. Perfecto. Now this just goes in here like so and... sweet. There's actually enough friction in the center bushing to suspend the base plate. Which is perfect because it means there won't be any side-to-side play, ensuring a very accurate and tight rotation. But it's still loose enough that I can easily spin this by hand. And man is it smooth. What a super rewarding start to this project. Oh yes, this is just the start. I still have to make the locking collar that holds us all together, and the mounting block that goes on the bottom, plus the pivot handle, and the pivot stops, and the fancy dovetail hardware. Okay, I've definitely gotten myself in deep on this one. I think I'm way beyond the point of this project being a reasonable return on time investment. But that's not always necessary with a hobby, is it? Nevertheless, I'm completely stoked about some of the machining challenges to come, and I'm especially excited to see if the mechanisms I've designed are actually going to perform the way I hope they do. But ultimately, I just hope this tool will make rounding parts a much more pleasant process. But those will have to wait until the next one, because I'm plumb out of time. As always, thanks for watching, and see you next time.